Okay, so this is the statistics review for Unit 2. I'm going to go over a couple things here, and this is a good questions to go over because it kind of covers everything that we covered, minus the density plots, which we'll get to. I'll look at one of those right now. I did go ahead and post the answers for the review guide onto the Google Classroom, so make sure you look at that as well. So let's go ahead and get into this. So here I see that a study elite distance runners found a mean body weight of 63.1 kilograms and a standard deviation of 4.8. Okay, assuming that it is normal, okay, make an accurate sketch of the weight distribution. So what I want you to go ahead and look at is how we're going to answer some of these questions. So here, normal distribution with mean of 63.1 and standard deviation 4.8. So this is the way we write it. So here they're asking me to actually draw this thing out. So remember, normal distributions are like this. Okay, where here they said the mean was 63.1. One standard deviation is 4.8, so I would just add 63.1 plus 4.8, which makes this one 67.9. Two standard deviations away, add another, you can't really see that, add another standard deviation, so another 4.8, so 72.7, and three standard deviations away, add another 4.8, so that would make it 77.5. And to find over here the negative standard deviations, I would subtract from the mean, so 63.1, minus 4.8, so this is 58.3. Over here, minus another 4.8, so 53.5. This is negative 2 standard deviations, and negative 3 standard deviations is 48.7. Okay, so that is the sketch of the normal distribution here. Okay, so next problem, part B, says use the 68, 95, 99.7 rule to find the proportion of runners whose body weight is between 48.7 and 67.9. So what I'm looking at here, guys, remember, one standard deviation away, this area was the 68%. Two standard deviations away, this was 95%. And three standard deviations away was the 99.7%. Again, this is from here to there, from here to there, from here to there. Okay, and so remember that, excuse me, if I were to break this up, what I'm doing right here, this is just something we need to remember. So this is half of 68, so 34%. This right here is 95 minus 68, which is 27%, and when I divide that by 2, it equals 13.5% in this little section. And these little sections, I know that they're drawn kind of big, but 99.7 minus the 98 is 1.7 divided by 2. So 0.85 in this section, 0.85 in this section, and in the final section it is 0.15%. So there's two ways I could go about doing this. Easiest way, since I already drew all these numbers, what I'm asking is from 48.7, so from right here all the way to, it says 67.9, so to over here. So from here to there, guys, I would just add up 0.85 plus 13.5 plus 34 plus 34, and now all of that equals 82.5. So the proportion of runners between 48.7 and 67.9 is equal to 82.35%. Okay, now in order to get this fully correct, guys, I mean, this is the correct answer, but we're going to be pretty picky about these, so I have to define what is x. So here, guys, just go ahead and write to the side, x is equal to the runner's body weight. That way we define it, we know what we're talking about. And what I've done here is, in order to get the full credit, I have to write the proportion, so we just got to be real specific here, of runners with a body weight between 48.7 and 67.9 is 82.35%. So using the empirical rule here, that is the proportion. Again, here they told us specifically use the 68, 95, 99.7 rule. However, I could have also used the z-scores, and I won't do it right now just because we are going to go ahead and do this later on, but I could have also done that. Okay, so what proportion of runners have body weights below 60? Okay, so if I look, guys, here's my normal distribution. I'm talking about 60. It falls somewhere in here. Okay, and so it doesn't fall perfectly on one of these 1, 2, 3 standard deviations. So what I'm going to do is I'm going to go ahead and turn this into a z-score. And remember, the mean for a z-score is equal to 0. So I want to know how many standard deviations I am to the, in this case, to the left, because the mean would be over here 60, so it's going to be smaller. Okay, so I'm going to use my z-score equation. So 60 minus 63.1 over, they told me standard deviation was 4.8. So my z-score is equal to negative 0.6458. Okay, so what I want is the proportion of my z-score, which is below. So again, guys, we're gonna have to shade here. If I'm below 60 kilograms, what I'm looking for is this right here. Okay, so I'm looking for when my z-score is below negative 0.6458. So there's two ways we can do this. We can either use the tables, which I don't think that that's the way to go here, guys. You can use them if you want to. However, I'm going to go ahead and use the calculator. So I will write this on the board for y'all for tomorrow. You go to menu, statistics. We're doing distributions, which is 5, and then we're dealing with the normal CDF. Okay, so remember, here what I'm dealing with is the smaller side, so the negative side, and then I go all the way up to negative 6458. Okay, so this number is okay, this small number is okay, and then my upper bound here is going to be negative 0.6458. So the proportion here is equal to 0.259. Okay, so again, guys, we do need to label X is equal to the runner's body weight. Okay, so when I'm filling out this proportion here, excuse me, to get the full credit, you have to write a little sentence here. So the proportion of runners whose body weight is 60 kilograms or less is approximately 25.92%, or you can just leave it like this, 0.2592. Either way is correct. I would just go ahead and just put the 0.2592. Okay. All right. So let's go ahead and do, I think D is going to be the last one for this video, and then I'm going to move on into a next one. So here, again, we're asking for proportions that are above 70 kilograms. So guys, if I have it right here, 70 is somewhere over here. So I should expect a standard deviation between 1 and 2, because 70 falls in between this range here. So again, we're going to go ahead and convert this to z-score. And if I'm talking about 70 or above, I'm talking about this over here. Okay. Now, again, there's two ways I can do this, and we'll get to the same answer either way. Remember, your z-scores are usually, your tables at least, they're usually made by filling in this side. So when I start to work through this, let's go ahead and find what that z-score is. Should be a positive number. 70 minus 63.1, 1.4375, which should make sense. It's between 1 and 2. When I find my proportion, it's greater than. Okay, so let's go ahead and find that. So doing menu, stats, distribution, normal CDF. Now I could do this two ways. If I do this the way I don't want to mess around with this and just go ahead and do over here this area. Okay. What I find here is that I have an area of 0.92, but remember that refers to what I have on this side, 0.92. So if I'm talking about this right here, this shaded area, then I would have done 1 minus 0.9247. So 1 minus that is 0.0753. Okay. Now you could have also just instead of you could have said your lower bound was the 1.4375 and then just say that this is just some big number. Just put a bunch of 9s here, and you see I still get the same answer, 0.7528. Okay, so two ways to go about this. Again, if you want full credit, you have to write a sentence. So the proportion of runners whose body weight is 70 kilograms or more is 0.0753. Okay, so that's it for this video, guys. Look out for the next one.